Vitamin D and vitamin K2, both fat-soluble nutrients, have emerged as critical players in the broader conversation about aging, inflammation, and cellular maintenance. Once viewed primarily through the lens of bone health, these vitamins are now recognized for their powerful roles in modulating systemic inflammation, supporting mitochondrial function, and influencing autophagy, the cell's built-in mechanism for cleanup and renewal. Together, they form a synergistic duo with implications that extend far beyond calcium metabolism, potentially serving as central components in strategies to slow aging and extend health span. Vitamin D acts more like a hormone than a traditional vitamin. Its active form, calcitriol, binds to the vitamin D receptor, VDR, which is expressed in almost every cell of the body. This allows vitamin D to influence the expression of hundreds of genes involved in immune regulation, inflammation control, and cellular metabolism. One of its most crucial anti-aging roles is in moderating the immune system. Chronic low-grade inflammation, or inflammaging, is a hallmark of aging and a driver of degenerative diseases such as heart disease, Alzheimer's, and metabolic syndrome. Vitamin D reduces pro-inflammatory cytokines and promotes the activity of regulatory immune cells, thereby preventing overactivation of the immune system and the tissue damage that often follows. Beyond immune modulation, vitamin D plays a profound role in mitochondrial function. Mitochondria, the energy centers of the cell, are both the engines of life and targets of damage as we age. When mitochondria become inefficient or damaged, cells produce more reactive oxygen species, RLS, contributing to cellular dysfunction and accelerated aging. Vitamin D supports mitochondrial integrity by regulating calcium flux, protecting against oxidative stress, and upregulating antioxidant pathways. It also supports insulin sensitivity and glucose metabolism, which, when impaired, can drive mitochondrial stress and cellular senescence. Crucially, vitamin D also influences autophagy, the process by which cells recycle damaged proteins, organelles, and other debris. In immune cells, epithelial tissues, and even neurons, vitamin D has been shown to upregulate genes involved in autophagic pathways. This effect appears to be partly mediated through the suppression of mTOR, mechanistic target of rapamycin, a major growth signaling pathway that inhibits autophagy when active. By lowering mTOR activity and supporting energy homeostasis, vitamin D encourages a shift towards cellular renewal and repair, especially important in aging tissues prone to buildup of dysfunctional components. Vitamin K2, while less widely known than vitamin D, complements many of these functions and fills in crucial gaps. Most notably, vitamin K2 is vital for calcium regulation, not by increasing calcium absorption like vitamin D, but by directing calcium into the bones and away from soft tissues. This protects arteries, kidneys, and other organs from pathological calcification, a common problem in older adults and a major contributor to cardiovascular disease. Through activation of proteins like matrix GLA protein, MGP, and osteocalcin, K2 prevents calcium from accumulating in places where it does not belong. However, vitamin K2's benefits are not confined to skeletal and vascular health. Emerging research suggests it too may influence mitochondrial function and autophagy. K2 participates in the electron transport chain in certain microorganisms and is hypothesized to have similar supportive roles in human mitochondria. In addition, K2 appears to reduce inflammation by modulating NF-B signaling, another pathway involved in age-related tissue damage and immune dysfunction. By reducing oxidative stress and preserving mitochondrial function, K2 indirectly supports the intracellular conditions that allow autophagy to proceed effectively. One of the most exciting areas of synergy between vitamins D and K2 lies in their shared role in cardiovascular and metabolic health. When vitamin D levels are increased without adequate K2, there is a risk of calcium mismanagement, potentially leading to arterial stiffening. But when these two vitamins are taken together, either through diet or supplementation, they promote both proper calcium utilization and the anti-inflammatory, autophagic benefits that support healthy aging. This pairing is especially powerful in the context of lifestyle interventions like intermittent fasting or carbohydrate restriction, which already aim to reduce insulin and mTOR signaling. In that environment, D and K2 can act as micronutrient catalysts that reinforce autophagy and mitochondrial renewal, rather than simply correcting deficiency. Additionally, both vitamins exhibit circadian activity and should be timed to enhance their impact. Vitamin D, produced naturally in response to sunlight, is best taken in the morning or early afternoon to mimic natural synthesis and support daytime gene expression patterns. Vitamin K2, fat-soluble and often consumed with meals, pairs well with dietary fat and can be taken alongside D to maximize absorption and synergistic action. In sum, vitamins D and K2 are far more than skeletal allies. They are metabolic regulators, anti-inflammatory agents, and facilitators of cellular renewal. Together, they help shape the internal environment that determines whether cells grow unchecked, fall into dysfunction, or engage in the deep cleanup processes that restore balance. By modulating mTOR, supporting mitochondrial health, and reinforcing the immune system's ability to remain calm and responsive, these vitamins emerge as quiet but powerful tools in the effort to extend health span. Their roles in autophagy, while still being fully elucidated, offer another layer of promise, one that ties nutrition directly to the core processes of aging and to the possibility of aging well.